In this video, we're going to try and find out the limit of sine theta over theta as theta approaches 0. So looking at this graph here, as theta approaches 0 from the left-hand side here, it's heading towards here. And if you approach it from the right-hand side, as theta approaches 0, it's heading towards this limit right here. Note that dead on 0 here is undefined. Okay, so to find out the limit of this here, we would imagine a circle of radius 1. So when you look at a circle of radius 1 here, theta is the angle right here. Now you've got to imagine that this black dots here, it's moving from here towards here. So as it moves from here to here, it's in a way it's the same as theta approaching 0. Okay, so here if you rotate it in this direction here, theta is increasing. If you rotate it in this direction, theta is decreasing. Well, to find out the limit of sine theta over theta, well, just like us finding out the limit of x squared sine theta, we would somehow track what we want to find out between two things. In this case here, we tracked it between x squared and minus x squared, and then we would use the squeeze theorem because, well, we would track what we want to find out between two things, and then as we take the limit of these two things here, it's forcing us into one place. Well, here we would use the same technique for this thing here. Somehow we want to create a scenario where this thing is tracked in between two other things here. Okay, and then take the limit of this thing, and then take the limit of this thing, and then try and force this into one single value where this would represent the limit. Well, just similar to this one here, our aim is to somehow track sine theta over theta between two things here, and then later on we're going to take the limit of these two here, and then somehow force this into one point. Okay, well, anyway, so looking at this unit circle here, looking at this circle here, if you look at this here, if you look at the area of well, hang on, in some of the earlier videos, I gave you lots of exercises to do where I would ask you to find out the area of this segment here. Okay, this area here, and it turned out to be the area of this segment here is theta over 2 when you work in radians, and then if you were to draw a straight line straight across here, okay, well, notice that our new triangle here, if you were to draw a straight line from here to here, okay, this triangle here will always be less than hang on, let me show you. So here we've got a segment here of a circle. Okay, that's one area. Now if you draw a line from here straight to here, okay, it will look like this. Hang on. It will look like this. So drawing a straight line there, the area of this purple triangle is sine theta over 2. Now if you don't understand why, watch some of the earlier videos. I gave you several exercises to do in preparation to this video here. So yeah, so the area of this triangle is sine theta over 2 when you work in radians. Now notice that there's a white area in between here. You see, my point is that this the area, hang on, this area here, from here, this area here is theta over 2. Okay, the area, this small area here is always going to be less than this area here. So we can write this. You see, we can write sine theta over 2. You see, this triangle here, this small triangle here, will always be less than this area here. Don't forget, this area here is this bit here. Okay, all the way down to here. Okay, And also if you so we can always say theta over 2, which is this area here, is always bigger than this area here. Okay, so we can make this statement. Theta over 2 will always be bigger or equal to sine theta over 2. Now, if you also look at this big triangle, where you extend the triangle beyond the circle, the area of this triangle here is well, this area here will always be less than or equal to this area here, the big one here. Okay, and again, in some of the earlier videos, I gave you an exercise on finding out the area of this triangle here. So if you don't understand this bit, then scroll back to one of the earlier videos. So we can actually make this statement. Theta over 2 is always less than or equal to tan theta over 2. Okay, so my point is that my point is that, hang on. My point is that this area here, okay, is this bit here, is this segment, this circular segment here, okay, and this here is this small triangle here. So this purple area is here, okay, and the big one, this tan theta over 2 here is this area here. So my point is that, hang on, bear with me. My point is that this area here, which is this circular segment here, is always in between. It's always in between this smaller triangle and this big triangle here. So we can actually write this statement here. Okay. Well, the area of this bit here is theta over 2. The area of this here is sine theta over 2. The area of this is tan theta over 2. Now, if you don't understand why the area of this here is sine theta over 2 and the area of this is tan theta over 2 here, then watch some of the earlier videos. Well, once you're here, you will get to here, and remember, our aim is to somehow trap sine theta over theta in between two things, and then take the limit of these two things here. Okay. Well, that's our aim, to somehow from here, keeping an eye on this bit here, somehow get to sine theta over 2. So our aim is to somehow get this bit here to sine theta over 2. Okay, so the next step from here, the next step is this. Well, if you so here you've got an inequality here. If you times everything by 2, then this bit will become this. Okay, and then times this by 2, then you're just going to get tan theta, and if you times this by 2, you're just going to be left with theta. Okay, so the next step is to realize that tan theta is actually sine theta over cos theta, because if you look at a unit circle here, again I gave you a video, and I gave you an exercise on this. If you look at a circle radius 1, the height of this here is sine theta. The length here is cosine theta, and when you look at tan is opposite over adjacent. Opposite, which is sine here, over adjacent, which is cosine here. So tan theta is actually sine theta over cos theta. Okay, and this is something that it must be ingrained inside your mind. Tan theta equals sine theta over cosine theta. Okay, this has to be ingrained inside your mind. So anyway, so here, well, just realize that tan theta is sine theta over cosine theta. So from here we would what? Hang on. We would, yeah. So currently we are here. Then now take the reciprocal of everything. So here, looking at this here, take the reciprocal of this. So if yeah, take the reciprocal of this, it will be 1 over theta. Reciprocal of this will be 1 over sine theta. But the thing is, when you take a reciprocal of an inequality, the sign changes, it switches around. Okay, and why watch? If you don't understand why, watch the previous video. Okay, and if you look at this bit here, if you take the reciprocal of this here, it will become this. Take the reciprocal of this, it will be cosine blah blah blah. Well, the reciprocal of this will be this. Okay, so we are currently here. Our next step would be, hang on, our next step would be what? Hang on, let me think. Oh yeah, so we are currently here. The next step would be to times everything by sine theta. So so here, if you times sine theta here, it gets multiplied to the top, giving you this. Now times sine theta here, it will get multiplied to the top. So you've got sine theta. Can you see? Our aim was to try and get from here to here, to track this sine theta over theta. Our aim was to somehow track sine theta over theta. So we started out as well from here we would get to here. Now again, looking at this here, remember we were here and then we times everything by sine theta. So so when you times this by sine theta, times by sine theta, it will get multiplied to the top. So here you've got one block multiplying another block and dividing by this block. These two are the same, so they would kill off each other, leaving you just cosine theta, Okay, and here this will become 1. And look at this, sine theta over theta is tracked in between cosine theta and 1. Okay, so now take the limit of this and take the limit of this as theta approaches 0. So that in a way, okay, our next step, we are currently here. Our next step is to take the limit of both sides. So here, take the limit of this side, which is this, okay, and then take the limit of this, which is this, and again we are taking a limit of everything as theta tends to 0. Okay, and then if you look at this here, the limit of 1 as theta tends to 0. Well, if you draw a graph of y equals 1, it would look like this. Now the limit as theta tends to 0. Well, taking the limit here from the left hand side, it approaches 1. From the right hand side here, it approaches 1. So the limit of this is actually 1. Okay, the limit of this here is 1. And then if you look at this here, the limit of this, well, if you draw your y equals cosine theta, it will look like this. It would look like this graph here. Now take the limit as theta approaches 0. Well, from the left hand side, when you approach 0, it's approaching 1. From the right hand side, when you're approaching 0 from the right hand side, it will also approach 1. So the limit here is 1. My point is that the limit of this is 1. The limit of this is 1. So you can see that the limit here is being forced in between. Well, you know that this here is always in between this and this. Now, if the limit of this here is being forced to dead on 1, and the limit of this here is being forced to dead on 1, then the limit of this thing here has to be 1. So my point is that the limit of sine theta over theta is actually, well, looking at this statement here, this can only be true here. The limit of sine theta over theta equals 1. Okay, so when you look at this here, this bit here is dead on 1. Okay, well, when you look at this here, the limit of this here is 1, and the limit of this here is also 1, and we know that this thing here is always in between this and in between this. Well, if this is being forced to 1, if this is being forced to 1, then we can only say that this has to be, well, it has to be 1. So there you can see that sine, well, the limit of this here is actually 1. Okay, and if there are some things that you don't understand, watch some of the earlier videos, because in some of the earlier videos I gave you several exercises to do that will lead us to understanding this. Okay.